Hi, this is Miss Park. This is the first of a few videos on trigonometry that go a little bit past beyond what we learned in grade 10, where all problems could be drawn with a single triangle and angles would only go up to 180 degrees to make a triangle and lots of other things that we were only concerned with in grade 10. But in grade 11, we actually go a lot further. So pay close attention. This part of the unit has a lot of new vocabulary. So I'll be writing down the new words as I use them. And then hopefully if you get used to the vocabulary, then this whole topic will make more sense to you. Okay, so we're in the booklet. On the page it says angles in the unit circle. And I'm just going to draw a couple things and I'm going to give you the new language that we're going to use. So a circle can be drawn by rotating a line segment about the origin. What this is saying is that if I draw my X and Y axes, then if I have a line, I can rotate the line around with the center at the origin, and then the point of my pencil will make this circle as I rotate the line. Okay, so that's how we're making a circle. All right, the x-axis. All right, so first of all, a circle can be drawn by rotating a line, which is the terminal arm, about the origin. So the terminal arm is this part of my pencil that's turning, like that. And it's a line that looks like this. So this is called the terminal arm. I'll tell you in a second why it's called the terminal arm. Okay, the x-axis is referred to as the initial arm and defines 0 degrees. So this part of the x-axis right there is called the initial arm. If you think about initial and terminal, initial means where you start, terminal means where you end, like to terminate, is where you end. And the angle is measured in here. The angle is measured in here. So if this was 45 degrees, then inside here would be 45 degrees. All right, but what we're going to do is we're going to measure the angle always from this positive x-axis. Let me just move this over for a second. This here is 0 degrees. So as we measure the angle, we're going to have measurements for the angle. But if the angle was just like this, then that's 0 degrees. Okay, an angle in standard position can be measured from the initial arm to the terminal arm. So standard position means the angle is sitting like this, with the initial arm sitting on the x-axis and the terminal arm somewhere. Okay, so that is standard position. We're going to use this language a lot. Okay, angles measured counterclockwise from 0 are positive. So it means if I measure the angle the way I'm showing you, 10 degrees, 20, 30, 40, 45, 60, whatever, up to 90, and keep going, those are positive angles. And I can keep going, 90, I can go 180, keep going, 270, keep going, all the way back, all the way to 360. And at 360, I've gone all the way around the circle and I end up back at 0. Okay, so 360 and 0 is really essentially the same thing. It's the same ending point. All right. Now, the next line says angles measured clockwise from 0, so in this direction, are negative. And we've never seen that before. We've never seen angles that are negative. It means if I measure the angle this way, I'm going to get a negative number. So let's say 45 degrees is going to be in this direction. Negative 45 degrees would be in this direction. All right, so I'm just going to write over here. This is a positive angle. And this one over here is a negative angle. Okay, there's one more thing we should add to this, which is the XY coordinate plane is divided into 4 parts, and we're going to talk about those parts in every question that we do. So I'm just going to grab another color and I'm going to name the parts. So these 4 parts of the coordinate plane are called quadrants. And okay, so quadrants. And the quadrants are labeled, they're numbered like this. This is quadrant 1, I'll call it Q1. And this is Q2. And this is Q3. And this is Q4. Okay, so these are the quadrants, Q1, Q2, Q3, and Q4. And it's very important that you know which one is where. All right, so the way to remember it is think about angles start at 0 and then they go this way, right, to get a positive angle. So that's how you number the quadrants. This one first, then this one, then this one, then this one. Okay, so I think we have all the things we need to begin. So that's the new language, and we're going to use this in every question. Now see where it says question 1, draw a diagram. I'm going to make a big deal about this because we are going to draw a diagram for every question in this unit. Every question must include a diagram. All right, so get used to it. So draw a diagram showing where the following angles in standard position lie in the unit circle. This is asking me to draw 135 degrees. Where is it? So I start by drawing my x and y. So I know that this is 0. And I'm going to go this way because I see that's a positive angle. So I'm going to go this way. So this is 90. If I go all the way to here, it's 180. But I don't go all the way to here. I need only 135. So the angle is this and this. So here's your angle. This is 135 degrees. This is how we label it. Okay, and I will write over here that it's in quadrant 2. All right, so I've drawn the angle in standard position. Let's do another one. 210, where's 210? So starting from here, and I'm going all the way around. So I'm going to have 90, 180. This is 270, so I'm somewhere in here. And exactly where it is doesn't matter. The important thing is that you're in the correct quadrant. So that's in quadrant 3. Okay, where's the other one? 90 degrees. So here's your initial arm. 90 degrees, the terminal arm is here. And that's how I would draw it. There's no quadrant. It's not in any quadrant. It's the y-axis basically. So I would just leave it like that. All right, let's do this -1. So -45 degrees. I'm going to draw. I'm going to start in standard position. So I'm starting at 0, but negative means I'm going to go the other direction, clockwise. This way, I'm going to go down. So -45 degrees is here. And the way I label it, I just put 45 degrees. I'm not putting -45. I can see it's -45 because it's going the other way. All right, so this one is in quadrant 4. Now you might also notice that this is the same as going in this direction 315 degrees. So I'm going to introduce a new word, and the new word is coterminal. So coterminal, the word co means together or the same, and the word terminal comes from terminate, which is ending. So it's ending together. It means it's the same. It's the same angle. It's gonna terminal arm is gonna be in the same place. So this is coterminal with positive 315 degrees. It's saying that if you go 45 degrees in the negative direction, that's the same as going 315 degrees in the positive direction. Okay, so new piece of language. Let's look at 330. So 330, I'm positive again. So here's 0, 90, 180, 270, and then 330 is going to be somewhere in here. And the way I label it is it's the positive angle. I got to go all the way around and end here. Yes, it's coterminal with -30 degrees. Okay, but they're asking me for 330, so I'm not going to bother with the coterminal. I did it here just so that to introduce the new word, but this is how you draw 330 degrees, and that's in quadrant 4. Okay, -225. Where is that? Negative 225, you start at 0. We're going to go in the negative direction. So this is negative 90, negative 180. This will be negative 270, so not quite there. So somewhere in between, like that. And I would label it this way, 225 degrees. Notice I didn't say negative 225. That should be obvious because it's going in that other direction. So this is in quadrant 2. Okay, new piece of information that's very, very important for us going forward. New language, related angle. Okay, so let's read. So the angle measured from the terminal arm to the x-axis within each quadrant. What? It's between the terminal arm and the x-axis within each quadrant. Let's do question 2 and figure this out. It's asking us to find, so draw each angle in standard position and calculate the related angle. So 30 degrees is going to be right here. I've drawn it. The related angle is measured from the terminal arm to the x-axis within this quadrant that it's in. So this is the related angle. So in this situation, my related angle is also 30 degrees. Let's do another one. 125. So draw 125. So 125, here's the initial arm. Terminal arm will be over here. Okay. The related angle is measured from the terminal arm to the x-axis in that quadrant. This here is the related angle. In here is the related angle. So the related angle is 180 minus 125, it's whatever's here, 55 degrees. All right, so in quadrant 1, you're always going to be, the related angle is the same as your angle, but in the other quadrants, it's going to be from where the terminal arm is until the x-axis, wherever this angle happens to be. 240. Okay, so 240, I'm going to be, so this is 90, 180, 240 is somewhere here. This whole thing is 240. My related angle is between the terminal arm and the x-axis. Yeah, I'll just draw it a little darker here. Between the terminal arm and the x-axis. This is my related angle. So the related angle for this one, so this is 180, x-axis is 180 plus another 60. The related angle is the 60. Okay, huge concept, this related angle. It's very, very important to us in this part of the unit. 320, go all the way around almost to the end. This is 320. Related angle is going to be between the terminal arm and the x-axis in that quadrant right here. So related angle is going to be, so here's your related angle, that's going to be 40 degrees. Right, 360 minus 320. All right, so now we have all our language. Let's go to the next page. All right, so I'm going to just kind of talk about this very briefly, but then I'm going to move down to the examples, okay? So we've seen now for the first time that angles can not only be greater than 90, but they can be greater than 180, and that's never happened before, because we always used to do word problems and trig problems inside a triangle where all the angles add up to 180. So you never had an angle that was 240. That never happened. So for us now, suddenly it happens because we can go all the way around the circle. All right, so I'm just going to start with this page over here just shows us here's a circle, here's an angle theta, and here's a point xy that sits on the circle. And what it's asking us to do, it says construct a right triangle. So I'm going to make a right triangle right there. And it's asking us to label the sides. So from this point to this point is going to be x. And from this point to this point is going to be y. So you're going x units across and y units up. Okay. And then it's asking us to write, using the diagram, what's sine, cos, and tan. All right, so I'm just going to write over here that I'm going to call this thing the radius of the circle. I'm going to call it r. And you can get that because this x squared, the Pythagorean theorem, x squared plus y squared is going to equal to r squared. So that's how you would get your r if you knew where this point was. So sine theta is going to be opposite over hypotenuse, so y over r. Let me write SOHCAHTOA here just so we don't forget it. Okay, cosine theta is adjacent over hypotenuse, so that's x over r. And tan theta is opposite over adjacent, so that's y over x. Right? Notice this triangle is in quadrant 1. Okay, this triangle is in quadrant 1. Now, let's do this again. So for quadrant 1, it's showing us, this is the triangle right here. So quadrant 1, but now with numbers. So it's 3 units across and 4 units up. Remember when I said we're going to draw a diagram for every question? So here we are. This diagram we have to draw for every question. So we're going to use this diagram here. So sine theta is going to be, now we're going to need the hypotenuse. So what's the hypotenuse? So you go 3 squared plus 4 squared equals r squared. And you'll get that r squared is going to equal 25. So r is 5. So sine theta is 4 over 5. Cosine theta is 3 over 5. Tan theta is 4 over 3. Okay, so far so good. But now what if I take that same triangle and flip it into quadrant 2? Notice it's the exact same triangle. I've just got it flipped into quadrant 2. And theta is being measured in standard position. So theta is actually outside the triangle. All right, so now what's going to be sine, cos, and tan? The size of the side lengths is exactly the same. It's just in a different location. So the numbers that you're going to get for the ratios are going to be exactly the same because it's the same triangle, just in a different location. What's going to be different is because of the different location, some of these coordinates are negative. So this is -3 and this is +4. Hypotenuse is still, you're going to square that number and square that number, you still get 25. So the hypotenuse is still going to be 5. But this adjacent now is negative. So when we're calculating our sine, opposite over adjacent, cosine, -3. Sorry, sine is opposite over hypotenuse, adjacent -3 over 5, and tan is 4 over -3, or in other words, -4/3. Right, doesn't matter. So you see what happened? That the numbers are exactly the same, but some of the signs, S-I-G-N, positive, negative, are going to be different depending on where the angle is. So let's say we take this exact same triangle now and just flip it into quadrant 3. Same triangle, same lengths of the sides, except because of the negative coordinates here, this is going to be -3 and this is going to be -4. My hypotenuse is still 5. I still get it when I square these two and add them and then take the square root. So now my sine is -4 over 5, my cosine is -3 over 5, and my tangent is -4 over -3, which reduces to 4/3. Again, notice same numbers, right? Because it's the same triangle, just in a different place. So of course the numbers will be the same. Last one, let's take our triangle and flip it into quadrant 4. So sine is going to be, okay, let's label this. So this is +3, -4. My hypotenuse is still 5. So sine is going to be -4 over 5. Cosine is going to be 3 over 5. And tangent is -4 over 3. All right. Question 2 says, in which quadrant is each primary trig ratio positive? So it's asking for sine, cos, and tan, which quadrants are they positive in? So sine's going to be positive in quadrant 1 and in quadrant 2, not in 3 or 4. So Q1 and Q2. Does that make sense that it's only positive in Q1 and Q2? It's because sine has to do with the opposite. It's got to do with this up and down side. Well, that up and down side is only going to be positive up here and up here. Okay? Cosine is positive. Where? Here I have a positive cosine. Not here, and also here. So Q1 and Q4. Okay? Does that make sense? Well, cosine is the one that's from side to side. And that's going to be positive on this side of the y-axis. It's going to be negative on this side of the y-axis. So that should make sense. And tan is positive where? All right, so let's take a look. It's positive here, and it's positive here, but not here and here. So Q1 and Q3. And why is that? It's because tan's only going to be positive when these two sides have the same sign. Either they're both positive or they're both negative. That's when you get this positive fraction. So they're both positive in quadrant 1. They're both negative in quadrant 3. And that's how you get the positive tan. All right, one last thing before we end this video is on the next page, there's a little rule that sometimes people like to memorize. As you know, I'm not a big fan of memorizing rules. I would rather that you understand and explain from understanding than memorizing a rule. But there is a famous rule called CAST. And CAST says, it tells you where each trig ratio is positive. So it tells you that cosine, let's go this way, that in quadrant 1, all of them, sine, cos, and tan, are positive. They're all positive in quadrant 1. So let's go back to our chart down here, the page before. You see, they're all positive in quadrant 1. And then it tells you that in quadrant 2, only sine is positive. And in quadrant 3, so here we go, quadrant 1. In quadrant 2, only sine is positive. Quadrant 3, only tan is positive. And quadrant 4, only cosine is positive, right? So that's what it's telling you, right? It's telling you which one is positive. And the reason I don't love it so much is because it's a memory tool, but also they start labeling this from quadrant 4 and they go C-A-S-T, C-A-S-T, but starting from quadrant 4, not from quadrant 1. So it's very easy to mess this up and start counting from the wrong quadrants, like start counting from here. Okay, so basically this is how you can remember which one is positive. But if you are going to draw a diagram for every question, there's absolutely no need to memorize which one is positive, because you can see from the diagram, when you do the trig ratio, you can see if it's positive or negative. Okay, but I wanted to share that with you because some students find it helpful. All right, and that's the end of the first video. So look forward to the next one, where we put all this information together and start doing trig without a calculator. So here we go, cosine 120 degrees, no calculator. How are we going to do that? So stay tuned, next video. Thanks for watching.